Skin is the largest organ of the human body, making up about 15% of the total adult body weight. Our skin is what provides us with protection against external chemical, biological, and physical agents, while also playing a vital role in thermoregulation. The various compartments of the skin provide critical functions in protection, absorption, excretion, sensation, and evaporation management, in addition to the most obvious use of skin, that being aesthetics. I doubt anyone would like to be walking around like that. The skin consists of three layers: the epidermis, the dermis, and the hypodermis, also referred to as a subcutaneous layer. The epidermis is the outermost layer of the skin, and it prevents pathogens and other foreign substances from entering the body due to its waterproof nature. The dermis is the thickest layer and is a connective tissue made up of extracellular matrix, and it includes fibroblasts, sweat glands, sebaceous glands, blood vessels, and nerve endings. The fibroblasts, which are the main population within the dermis, secrete collagen and elasticin, which provide mechanical and structural elasticity to our skin. Below the dermis is the hypodermis, which is composed of adipose tissue and provides cushioning and insulation between the skin and the skeletal structures, while also serving as an energy storage area. The initial response of homeostasis is taken in order to maintain health. It is achieved through clotting any damaged regions with the use of circulation platelets within the blood, which form a fibrin clot in order to prevent blood loss and possible infection from happening. Additionally, vasoconstriction and vasodilation take place, isolating the wound site and providing it with the required healing cells. The inflammatory response prevents infection and clears the wound site of debris, while also preparing the skin for the next step, the proliferative phase, during which new tissue and extracellular matrix is laid in order to support tissue repair. Then, four processes take place. First, revascularization, in which new blood cells form around the wound site and supply cells with necessary nutrients for remodeling. Then, granulation happens, where fibroblasts create temporary extracellular matrix for the reconstruction of the epidermis. This is followed by reepithelialization, at which point the epithelial cells around the wound site stretch in order to cover the wound site, and once a continuous epidermis is formed, they then begin dividing. Finally, contraction happens, where the myofibroblasts around the wound pull the site together in order to decrease its size. The final stage of wound healing is remodeling, in which the normal tissue strength and function are finally restored. That was the normal physiology of what is supposed to happen when a wound is sustained. However, in many cases of severe, deep injuries and burns, the healing process can be interrupted or things can simply go wrong, leading to chronic wounds, extensive scarring, decreased normal function, and even the development of fibrosis. Wounds that don't go through the phases of healing in a timely manner are at high risk of becoming chronic. Possible causes include conditions such as diabetes mellitus, compromised nutritional or immunological states of the individual, vascular insufficiency, or simply old age. Over the years, many different techniques have been tested in order to treat wounds, including skin grafting with autografts, skin allografts, xenografts, and amnion. These treatments, while sometimes efficient, are considerably high risk and outdated to say the least. Two of the most promising developments in the past year include 3D skin printing and regenerative artificial skin. Princeton University has recently funded a grant for a promising project aiming to build artificial skin for wound healing and therapies. The aim of the project is to create lifelike skin containing the same mechanical properties, cell types, and necessary bacteria found in the human skin. They will do this by developing a platform to print skin cells, microbes, chemical release agents, as well as a polymer matrix with a self-healing material composed of biocompatible hydrogel particles. This is different to other approaches which contain activities of cells, as the created environment will allow cells to migrate, grow, and self-organize, while allowing the researchers to gain a deeper understanding of the skin process overall, as the hydrogel medium is clear itself. An additional development, which is rather promising, is regenerative artificial skin, which is used as scaffolding around which new skin cells can develop. The product is made up of shark ligament and cow-determined collagen, both proteins of which are found in all connective tissue of humans. This base layer is then secured onto the injured site through the use of a sugar particle called glycosaminoglycan, which mirrors the surface of the lower epidermis. This base is then sufficient to wrap skin cells such as fibroblasts, allowing them to begin producing human collagen, which in turn leads to this tissue stirring its way up the counterfeit framework and gradually constructing a new dermis layer. After the job is done, the framework breaks down and no evidence of it is left. Both of these developments seem quite promising for the future, and researchers are continually working to come up with innovative ways of overcoming chronic skin conditions such as chronic wounds and bad burns. Considering the funding and research effort being put into such studies, the future for the development of flawless artificial skin is looking really bright. Thank you for listening.